Welcome to Neat Dream Warriors. Thank you very much for choosing to watch this video. In this video we will know the basics of physics completely. Come on, let's go to the lesson without delay. I could imagine that even the earliest human beings, or possibly pre-human beings, had asked themselves the questions. Why am I here? What is the nature of reality? Why is the universe organized the way that it is? And these questions are what we attempt to answer in the field of physics. In the field of physics, which you could view, maybe right after mathematics, as the purest of the sciences. So, you have math, which is very pure. And then on that foundation of math you have physics. And physics really does try to use that mathematics along with some core ideas to explain the phenomena, all the phenomena, of the universe. And physicists will be the first to admit that they are just beginning to understand the nature of reality, the nature of everything around us. Now a lot of times, we think physics is only limited to things like cosmological phenomena or getting rockets into space, or how waves move or building structures. But physics is the foundation for all of the other sciences. When we think about chemistry, which is at the end of the day interactions between atoms, those interactions are really physics-based interactions. So chemistry is actually laid down on a foundation of physics. And then even when we think about ourselves, our bodies, even our consciousness, our brains, it really all boils down to chemistry and physics. So this is biology right over here, which is built on a foundation of physics, which is highly dependent on some of the math that you've been learning your whole life and that you will continue to learn. Well, you know, why am I learning this math? Well, 1, 'cause the math is beautiful, but also you will see that it starts to, in almost the most pure way, describe the structure of the universe. And we're going to see that more and more as we go into physics. All of this complex phenomena that you see around us, whether we're looking at a galaxy or we're looking at ocean waves, or we're looking at even biological systems, we'll see that a shocking amount of them can start to be described using some fairly elegant mathematics that we can build on and continue to build on. Simple or elegant mathematics like force is equal to mass times acceleration. And we're gonna talk about force and acceleration as vector quantities. We're gonna think about things like displacement, and I'll put it as a vector quantity, and we'll soon learn more about vector and scalar quantities are. Displacement is equal to velocity times. We'll learn things like acceleration is equal to change in velocity over change in time. What we'll see with even a handful of very simple ideas like this. We'll go into much more depth in future videos. You can explain all sorts of complex phenomena. And the one thing that I always loved about physics, and I don't think it's always fully appreciated. Sometimes as you start to learn physics, you'll see all these complicated formula, all of these kind of complicated problems, but it's super valuable to realize it's all coming from some of these basic ideas. Some of the things that I just mentioned, these ideas, we're gonna explore ideas of energy. We're going to explore Newton's laws. We're going to explain, we're gonna think about what are the different types of forces out there, and why they might, why they might actually exist. At its essence, it's all about trying to explain the complexity of the universe, predict what is going to happen based on simple ideas, and that's what physics is all about. Now when we think of physics, it's been studied by humanity for a very, very long time. In fact, I'm sure we don't know who the first physicists were. But some of the, I guess you could say, foundational thinkers in physics are these gentlemen that I have here. And this is just a. You could kind of say this is some of the most prominent thinkers in physics, but this is by no means a complete list. First and foremost, we'd wanna include Isaac Newton. Especially when you start to study physics, you're starting to understand the world as Newton understood it. Even classical mechanics, the physics that Newton established, can explain a large range of phenomena with amazing precision. But as we get into the early 20th century, physics starts to get even more wild as we start to look at the scales of the super small, and we have Max Planck giving us quantum mechanics, and then we have Albert Einstein as we start thinking about super fast speeds, the speed of light, and we realize that's an absolute. That nothing can travel faster than the speed of light, which is this mind-boggling thing that we have these notions of general and special relativity, and we start realizing that the universe is in some ways more bizarre, and more mysterious, and more fascinating than we ever could have imagined. But all of the work, even to understand the modern physics of Max Planck and Albert Einstein, it's based on a lot of the core ideas that were given to us by Isaac Newton, even people before Isaac Newton. So as you go into your study of physics, and I'm kind of a physicist wannabe. I wanted to be a physicist. I imagined kind of, 'cause it's all about, we all wonder, why are we here? What is the nature of reality? Why do things happen the way they are? And these are the questions that physics is attempting to answer. And so as you go into your study of physics, I want to leave you with some quotes from these three gentlemen. So the first two are from Isaac Newton. Truth is ever to be found in simplicity, and not in the multiplicity and the confusion of things. And I really wanted to stress this, because a lot of times in your studies, you might be finding yourself memorizing formulas and vocabulary, but that's, if you're doing that, you're just at the very surface. But if you really start to think about it, really start to think about where these things come from, it'll come to simpler and more intuitive ideas. And then, you are getting closer to the truth. Now, I love this second quote from Isaac Newton. I do not know what I may appear to the world, but to myself, I seem to have been only like a boy, playing on the seashore, and diverting myself and now and then, finding a smoother pebble, or prettier shell than ordinary, whilst the great ocean of truth lay all undiscovered before me. I like to imagine there's so much, even though we think we know so much, that we haven't even learned a small fraction of how the universe really is. How does the universe actually work? And if when we start to think about these, you don't get a few chills on your skin, a few goosebumps, and feel that the universe is more mysterious than you thought, then we're not studying physics the say that we should be studying physics.